Okay, so what all those prefixes mean are how many carbons are strung together, how many carbons are in a chain. Now, the cool thing about hydrocarbons is that when you break those carbon bonds, that's where energy comes from. The energy is stored in those bonds. So obviously, if you look at something like heptane, which is how we derive gasoline, there's a lot more energy stored in those bonds than there is in something like methane, which has fewer bonds. And you can see that you can get carbon chains that are huge. 26 carbons, petroleum coke. What is that? Sounds like something that gets you in jail. So you see that the formulas, once again, follow patterns. But what I am most interested in this chart are the boiling points. That's the important part, okay? Because what we can do is take something such as crude oil. This is what actually comes out of the ground when they drill or discover oil. And there's some water in there, and you can see it won't mix, it's separate. But crude oil is this thick, black, disgusting, sticky, gooey mix of hydrocarbons. So it's got all of that stuff in it. We have to be able to get all these apart. And we do that by heating it up. Because they have different boiling points, they're able to separate. Now, how does this stuff actually form? Remember, I taught you that coal forms in swampy areas. Well, it turns out that oil is a lot more marine-based. That's why we drill for oil offshore. That's why a lot of coastal regions have much bigger pockets and distribution of oil in the ground. Now, it still requires immense heat and pressure, millions of years for that oil to, for the organic compounds to decompose and form oil. But just to show you how much energy is involved in formation of things like coal and oil, I mean, this picture shows you the tremendous amount of force that's inside the earth, a force that's strong enough to literally bend rock layers that have been there for thousands of years and put them in all sorts of funky shapes. Geologists have names for all of these. These are called folds, because an anticline is where you will most likely find pockets of crude oil. Here's where the name anticline comes from. I think it's easier to remember syncline. A syncline is when it forms a smile. Remember, they both start with S, and it's S-Y-N. C-L-I-N-E. Syncline is a smile. But if you're unhappy about something, if you're protesting something, that's anticline, and it's the opposite of a smile. So that should be easy to remember. An anticline is this kind of hill-shaped fold that happens in the rocks. Okay, so there's a picture of one on the left. And we also call this geologic formation, we call it a trap, because you can see the oil gets trapped in that peak. It gets pushed up in there and is stuck. Now, what actually makes it stuck? Why does it stop in that layer? Well, if you notice the names of the rocks, the pink one is called sandstone. Sandstone is made of sand, and you can't really notice or feel them, but there's tiny little holes in here that water can move through and oil can collect in. So that's called the reservoir rock, because it's got space, just like an aquifer can hold water, a reservoir rock can hold oil. And then on top of it, we've got this really squeezed, and this forms in oceans. It's called shale. And shale is squeezed really tightly together, so there's no spaces in it. And so it's the cap, like the hat that goes on top and blocks everything from getting through it. Okay, so that's what a cap is. A cap rock is impermeable. Now, we've discovered in the last 80, 90 years, this rock called shale, even though it's impermeable, because it formed in the deep ocean, it's got oil in it. In fact, there's one variety called oil shale that you can literally light on fire. The rock itself will just burn. I don't think this is oil shale. But we're going to talk about fracking probably next week. And fracking is where we break this rock apart because there's gas and oil trapped inside of it. And so if we shatter this rock, we can get even more oil out of the ground. And we can pollute our earth even more by burning it. That's a bad thing. So it's a rock formation that holds oil. Now, sometimes the oil can come up all by itself. In the old movies, they talked about, oh, there's oil coming up out of the ground. That's when you get a crack, which is called a fault. And so oil might, because it's under pressure, be able to leak up to the top. But generally, we dig wells, we pump the oil up manually. What oil geologists do, they go to a likely formation and they drill down into it and pull out what's called a core sample. And they just check the core sample. Is there oil in it or not? And once again, it's typically the pore space that determines how much oil is in there. And remember, if there's more pore space, it's more permeable. If there's enough oil to be profitable, then they buy up that land and they secure the rights to drill it and onward with their oil company. You can see the left image there has lots of oil in the core sample and the right one has almost none. Okay, so at this point it's time to get the oil out of the ground. And there's lots of different ways that we do that. There's traditional pumps that are used. There's oil wells that they can open and close that are under pressure. This is a high-paying job. If you want to make money in environmental science, go work for an oil company. But the work is tough. It's dangerous. It's dirty. The people who go work on the oil rigs that are offshore in the oceans, they're away from their families for months at a time. Okay, so we got the oil out of the ground. What next? A barrel of oil is 42 gallons of crude, C-R-U-D-E, crude oil. And once again, crude oil is just a mixture of hydrocarbons. So the next step is to move that oil, if we need to oil refineries. Oil refineries look like what you see in the picture. What's happening inside of those towers is called fractional distillation. Now you might remember this concept from chemistry. Distillation, if you distill something, you're heating it up and separating it. We can distill water and get all the impurities out of it. So fractional means we're doing it in chunks so that we can take the hydrocarbons out one at a time. So in these tubes, once again, they heat up the crude oil and things have different boiling points. And you can see the heaviest hydrocarbons, the ones that have the longest carbon chains, they come out at the bottom. They're more dense. And the ones that have the least amount of carbon, methane, ethane, propane, those all go to the top. And so we invent a little trap system which collects the heavy ones and the light ones keep moving up. And these are the different products we make from petroleum. So we can make everything from tar that goes into roads to diesel fuel for trains and boats and trucks, petroleum products like waxes and polish and lubricant, jet fuel, gasoline for our cars, and of course, natural gas products as well. It all just separates out in big towers. And then they can ship the different products to whoever wants or needs them. Now here's a map of the major refineries in the United States. And every once in a while, you may notice gas prices shoot up or they drop, and it never makes much sense. Like, oh my gosh, why did gas change 40 cents a gallon overnight? It usually has something to do not with the gas station itself or with the economy. It has to do with refineries. Sometimes refineries have to slow down or even shut because they have a safety problem or an inspection, or they're upgrading something or cleaning it. And so when refineries close, that disrupts the entire system because they have to take the refined gasoline from these plants and move them all over the country. Now you can see Indianapolis is pretty well connected. We have huge refineries up by Chicago that can supply us quickly if need be. There are a couple dead spots throughout the country here, though. You see the Southwest. I mean, not many people live there, so it's not high priority. Now, next week, we're also going to talk about pipelines and some of the dangers with them, but we have pipelines all over this country. Most of them are underground, so you don't even notice them. And just for the record, they leak. A lot of them leak. Some of them leak pretty bad. Some of them are really old and they need to be upgraded. But if we're going to abandon things like oil and coal, maybe we should not upgrade them and just be done with them, right? This is all the old infrastructure that we have to deal with. Think where hurricanes hit. Hurricanes hit this area of the United States, right? And look at how big the refinery operations are there. When it's hurricane season, they have to be on guard. And if a big storm rolls through, they shut these refineries down. That's why gas prices shoot up again. In the Bahamas, when they got slammed by Hurricane Dorian, the refineries down there leaked. And we discovered almost 1 million gallons of crude oil that had been spread around all of the Bahamas by that storm. So building these things in areas that get big storms is problematic. But that's also where the oil's at. So that's why we build them there. Okay, just like coal, we have pollution associated with extracting and processing petroleum. We don't get coal ash, but we do get tailings again. Tailings are any of the leftover products from crude oil that we can't use. These things are toxic, and we put them in big ponds. Now, I want to define the top word for you. It is pronounced subsidence. And really, this would apply to any type of mining as well. But when we pull out big reservoirs of oil or gas, there can be shrinking or settling of the ground. That's how I would define subsidence, settling of the ground. So anytime you remove something, there's going to be gaps and weakness, and over time, the ground can sink or even fracture. You could have small earthquakes. Just like mines, there are regulations now about cleaning up extraction sites, right? Reclamation, we called it for coal mines. But that's not true everywhere in the world. You're looking at an abandoned oil field in Kuwait. Remember, the Middle East is actually the biggest abundance of oil and gas. And their laws are nowhere as tight as ours are, their regulations. And so when an oil field dries up, they just walk away and they leave this toxic mess in place. And I hope you have a lovely weekend. There will be an assignment for you on Monday on Canvas, and I will see you live on Tuesday. Take care.